Good afternoon, everyone, and welcome to the 2019 Sloan Sports Analytics Conference workshops brought to you by Rakuten. My name is Philip Tu. I'm a second-year MBA at MIT Sloan, and it is my pleasure to introduce Mike Denowitz, Engineering Director at Condé Nast, who will be running our workshop, Scraping with Python 3 today.
Thanks.
So a big round of applause.
Hey everyone, my name's Matt. Who here has experience with Python? Doesn't matter what version. Oh, do we still need to do this? Okay, so I know it's the end of a long weekend. Everyone's throwing a lot of stuff at you, and given that they saved the best for last, I'm gonna really throw a lot at you, and then we can all go to the bar. Does that sound like a deal? All right, very good. So I'm Matt. I oversee Condé Nast subscription products right now. My background is in web development. Before that, I was with a music magazine called Pitchfork for the better part of a decade. We sold to Condé Nast. I stayed with Condé Nast. On the subscription side, we run a lot of our user data platforms, all this kind of stuff. We don't do too much scraping, but on the next bullet point, we do. So I also work with a couple of baseball writers. Some might be here, some might not be. And then professionally with a couple of clubs through another LLC. Just to work on data. So we scrape data, we combine it, we push it around, and then we also work with like StatCast. A lot of this talk is going to be focused on baseball. I know it's the most exciting sport. It's definitely had a great off season. If anyone wants to talk other sports afterwards, we can definitely go through like similar examples for pulling together NBA draft comps or something like that. On the side, I do have a lot of side projects that just like pull sports data. My GitHub is full of baseball scrapers. I also have an interest in modular synthesizers, which is way beyond the scope of this also niche topic. But for that and for baseball, we pull in like research, we scrape that stuff, store listings, all sorts of things like that. You can find me on GitHub, same username on Twitter. Probably not a lot of value on the Twitter side. Guess that's what it's there for. So that's me. Here's what I want to cover today. We're going to cover the necessary background on scraping. Not going to get too pedagogical on this. We're just going to talk about what scraping actually is. Define a usable framework, which is kind of just like a methodology, a couple strategies you could use every time you want to scrape. We're going to look at applying that framework then to 3 sites. This might feel a little front heavy on the theory, but once we get past all of that, I think you'll understand why the framework works when we look at 3 different sites. We're going to pull Major League Baseball prospect lists from 2019. And then if there's time at the end, we can talk about how we would glue them together. Not exactly scraping, more like the compositing side. And hopefully we have a good time doing it. Now, at the bottom here, if you want to follow along, I did put together a GitHub repository. Follow that link, it will take you there. It's got setup instructions if you want to clone it. All you need is Python 3. It'll tell you to make a virtual environment. It will then tell you to install the requirements. And once you're there, you can run your virtual environment's Python interpreter probably without any trouble. If at the end you do have trouble after all of this, let's talk. I can try and like debug for you. Mostly this is done in a way that should be platform agnostic, so it should work well in Windows, especially if you're using like the Windows subsystem for Linux. I'm running Ubuntu on this because I don't value my life, and it also works on Mac. Cool, let's dive into it. So what is scraping? You may think of scraping as stealing information. On one side, you're going to a website, you're extracting information from it. On the other side, you get kind of this like mythologized character, mythologized, maybe like Aaron Schwartz, who's freeing information for the masses. But at the core, what you're really doing is you're taking a data source and you're taking something useful out of it. We call this information extraction. It's a little different than what you might have heard for like IR or information retrieval. Information retrieval would be like going to Google and with a specific query with the expectation of pulling like relevant documents back out. In this case, we know the information that we want to find, so we're not searching for it. We're figuring out how do we go into the source and how do we pull it back out. Here's the technical definition. I would like to dive in a little bit more for this because these definitions are a little bit long. So structured information is what you want at the end of your scrape, right? That is going to be concretely organized. It's got fixed data types. If you've used Postgres, MySQL, any kind of relational database system, that's going to be a structured data type, right? Semi-structured information is probably the majority of what you're going to be pushing around here. That's going to be going to a web page, working with CSV data, where CSV data has like characteristics of organization, but no like enforcement of that organization necessarily. XML and JSON. Is everyone familiar with these formats? Generally? Okay. We're going to touch on JSON later and HTML. CSV and XML, not so much, but we will touch on XPath. Is everyone here generally familiar with XPath or has heard of it before? No? Okay. XPath is a querying language for XML. Any XML-like structure that you have, such as HTML, can be queried simply by saying, and you'll see an example of this later, I want to start at this element and then continue down through the tree until you find certain attributes that match. Once you find those matches, you have those attributes. A concrete example of this would be, let's say I've got an entire HTML document, and I want to find a specific table within. I can say, give me all the tables, and then match certain characteristics until I find exactly what I want. This will be handy when we start looking at one of the sites out there which has all of its data in an HTML table. Unstructured information does not follow any sort of schema, has little no predictability. If you open up your email, Twitter is a really good example of this. There's been a ton of academic research over the last few years into creating natural language processing libraries that work on Twitter because people use shorthand, people use just insane examples of made-up language. There's a tweet that I saw right before coming in here. Pitcher list had a GIF of a Noah Syndergaard pitch from earlier today, and it said something like, "Putting the 99-mile-an-hour ched." It's like, how would any researcher reasonably parse that? Yeah, so strings of text, email, a photograph. Photographs are interesting too because you can mine them for text. There's a lot of technology out there that will look for branding on clothing. That's scraping. There's a lot of technology out there that will look for pose detection. That's also scraping. You'll see different variations of scraping. There's web scraping, there's screen scraping, which is something visual. We'll touch on that. Just as kind of a concrete example, here's unstructured text. This is from MLB Trade Rumors. This is just something they posted earlier today. Bryce Harper be available to the press. Now, if you were to scrape this, your ideal output here would be something like you can identify the Phillies as an organization, Bryce Harper as a person, Clearwater, Florida as a location, and so on. The relative time is interesting because that kind of implies you're going to be doing a little bit of extra work looking at context around that information to figure out what am I looking at. It's not exactly scraping, that kind of gets into like natural language processing, but in this case you would probably look at that and then look at the blog post as the relative time. And just a few more examples to belabor the point. We're going to be reading rows of data from HTML, extracting text. Pulling metadata is kind of a really big thing. If anyone's really doing like web scraping for article content, you're going to be looking at like certain metadata tags that probably inform better than freeform text would. Frames from video, and if you've ever, let's say, traveled internationally and had to open like the United app or some other airline app and scan your passport, and it magically finds the number, fills in the information for you, that's screen scraping. It's pretty cool. So that aside, now that we all know what scraping is and have a common language, here's the framework. I like to think of this as kind of like Ocean's 11 because when you're just coding over unstructured data after a while, it gets so tedious. You got to spice it up a little bit. These are the 4 steps. Apply these every single time, and you're going to have a very, very good idea of what you're going for. Just to translate these, this should look familiar to basic research patterns, right? So you're going to have a discovery phase. You're going to like interrogate yourself as well as what you're trying to scrape and take away a good cohesive idea of what the output should look like, right? You're going to do a little research. Before you practically apply anything, you need to figure out what you're actually like getting your hands dirty with. Then you want to go in, design and validation phase is going to be where you're prototyping your code. And then you're going to validate your ideas. You're going to make in a lot of assumptions here. You need to validate those assumptions along the way, and you also need to figure out how am I going to save myself from a lot of trouble down the road? What edge cases do I have? What happened if my validation or my assumptions change? And then you're just going to write the code. That's the fun part. So let's take a look at the first step. This is kind of like an archetypal view of what do I want. You're going to ask yourself that every time. Let's have a good idea from this. When you start, you want to look at something. You want to say, I want prospect listings. I want WAR from Fangraphs, something like that. You need to understand how you get it. Is it on a single page? Am I going to have to visit multiple pages? Is it in multiple sites? Is half of it for free and the other half sitting in some kind of like paid journalistic repository, right? Next is, what format is my source? Am I opening a PDF? Am I scanning email? How do I access that source? Is it over the web? Is it via FTP? Is it some other method, right? Is it going to a library and scanning documents? After that, you got to think, how do I want to output this? What do I want at the end? Do I need some kind of structured data to feed into a database? Do I need, I don't know, whatever else you might need? Do I just need to have this like emailed out to somebody? Is this a report at the end of the day of you saw so many instances of X? I don't want to get too deep into like additional transformations or what comes on the output side, but we'll look a little bit later. This session and the code that we look at assumes that you just want CSV, because CSV is super portable. You can import it right into a database, and everything reads it. Next step, got to look around. Got to see, how am I actually going to do this? First, ask yourself, are there preconditions? When I built the Baseball Research Archive, Sabre Archive, one of the biggest problems I had wasn't that it was hard to access the data. It was, one, that it was all unstructured, and two, a lot of it sat behind paywalls. So if I needed something from Baseball Prospectus, I gotta log in. That means I have to automate logging in. That means when I deploy something to production to run on its own, I have to have credentials stored securely somewhere to be read before I can access this stuff. If they change, as they did when the redesign, how people log in, now I gotta rebuild the entire scraper, which is something to consider. Other things are firewalls. A lot of people have bot protection, a lot of large sites. I can't think of any off the top of my head. We use Cloudflare in front. Cloudflare will make you like execute a little bit of code to prove up front that you're there. Other times, let's say if you're calling Fangraphs too fast, Fangraphs will pop up just a page with a reCAPTCHA module. And if you're not familiar with that, it's a way that Google will let site owners ask you to verify that you are in fact human. Other things, geo-specific restrictions, sometimes contents, say you're watching Netflix and you want to get some data from there and you go to Canada and now that particular video is not there. And then the same, PDFs are a proprietary binary format. MP3s, same way. Sometimes you have to decode those, you need special libraries, that's just extra work. Next step, is the data self-contained? So you have a good idea of where this is, but is it actually where you think it is? Or is it loaded via API? Another example, this is a deceptively simple example. I've given this as a coding test at Baseball Prospectus before. Let's say you want to take the big three WAR manufacturers and you want to bring those numbers together. And you need to do that by Major League Baseball ID. None of these sites, Baseball Prospectus, Fangraphs, or Baseball Reference, offer on the page that ID. They have their own vendor IDs that you need to take and then match to another data set. So that automatically implies another data set that you need to go and find. Next, minimize the amount of unstructured scraping that you do. We'll look at this next, but you have many, many ways on a web page, for example, and many, many proprietary formats that come with documentation to tell you exactly how to reach into something and find it. You also get a lot of hints. People are very good at, at the HTML level, let's say, of hinting at exactly what an element contains. But just to drive this point home, this is from a site that I scrape. On the left, that's pretty well structured data. I know if these tags are on the page, I don't have to do anything else. I do still need to parse the $, if you can see the mouse out of that, but I at least get this. In the real world, if this was a proper implementation, they wouldn't have that $sign there, right? Because the currency is already specified with the price currency. But those attribute names and the structure of the item prop offers and the item type of schema.org/offer that's essentially a contract, right? That I know it'll be in that format and ready for me to parse. My other option is on the other side, I can just kind of wing it, and now I've got to look for an ID of product price with a class of H1, which doesn't really make any sense because in HTML H1 is only supposed to appear once. And I've got kind of like a string with a $, and then I've got the sense up in a super tag. It's not great. So then as you continue, you're going to be writing code, and you're going to hit a snag. Sites are going to block you. The site might go down, something might change in the interim, or data just might not exist. As we're going to find, sometimes you're looking at a prospect list, and every player has a link, but not every player has a system ID. So you got to be ready to catch that, right? That's just something you bake into your assumptions. And then you want to design scrapers so that they can be run over and over and over, because they might be running hourly, they might be running nightly, they might be running yearly. Everything makes sense so far? I know this is a lot. Good, all right. So when you get started, you'll start with a small set of documents. And that's because you don't want to give yourself 3 gigabytes of information to parse and then have all of the edge cases hit you at once. That's not great. What you really want is just a nice sample. So sample your data. Bring it down locally too. Please don't hammer servers that you're trying to hit. They will block you and then you're just SOL. Poke around. See what happens when you change things. Every time you write a line of code, you make an assumption. Every time you write an XPath or a CSS query or any kind of logic, that is an assumption. That means it's going to have to be tweaked later. You're going to validate these, you're going to find edge cases, you're going to keep going. The biggest one is that when you validate all of these ideas and you've got your subset of data, you can then very easily extrapolate how long this is going to take. Some of that is going to be trial and error, like learning how fast it takes for a site to block you, and others just looking at it saying like, well, it takes 1 second to load this page, I'm doing everything in serial, so it's going to take n times 1 second. And if you've got all that together, you're in pretty good shape. You got a durable, repeatable scraper. You understand the assumptions underlying performance characteristics. You've minimized the amount of unstructured scraping, which just disambiguates all future work. And you've promised not to just completely blow up wherever you're stealing the data from. You're ready to go. Now, if you take a picture, it's not going to get the animation. Cool. All right. We're a little ahead of schedule. That's not too bad. Am I going too fast for anyone right now? Okay. Just as a quick interlude here, I wanted to say that in 2017, I did the same presentation. So I rebuilt it this year because we spent a lot of time talking about data formats. Very glad that everyone's familiar, at least with like XML, CSV, JSON, things like that. So we're probably going to have some time here at the end. Probably about another 30 minutes, maybe 25 or so to get through all of this. I'm going to walk you through how to kind of like probe different sites for information. If at the end you have specific questions about like other sites, let's give it a try. Certainly not afraid of any live coding, contingent upon the Wi-Fi here. So with that in mind, 2 things to show. One is we built up this idea you can scrape anything you want with code. You came here to look at scraping with Python, but I just want to say with the real world example, you don't always have to write code for this. There are other tools out there that will like automate this for you. One of them is Google Docs. Google Docs has this really cool function called import HTML. Syntax is on the screen. Now, the other day, I do some contracting work with Baseball Prospectus. In my capacity there, I'm the StatCast platform architect. Very fancy. Part of that is pulling in data from StatCast. Another part is pulling in like information from other sites, coefficients for WOBA, for example, or part factors, just so we can compare numbers, right? And I get in a conversation with Rob McCown. They're absolutely brilliant, really just like everything engineer. He asked me like, hey, do you have a scraper for Fangraphs guts page? Fangraphs guts page is just one large table of all their WOBA coefficients, part factors by hand, things like that. I say no, and I start thinking like, oh, that wouldn't be too hard to write a scraper for. Then I remember it's just one table. I don't want to have a piece of code that I have to maintain in perpetuity around this. It's just one table. So I, bought my old friend import HTML a beer, and we got to work. Here's what that looks like. If you want to try this on your own in Google Docs, we can try it later. I can show you on the screen live. But roughly, this is the URL you enter. You have import HTML. You drop in the URL, specify a table. And this is the zero-based 4th table on the page. I think it's zero-based, trial and error. So you can see it drops the whole table right in there for me. Done. It's great. The other nice thing is that we'll just update every time I revisit the spreadsheet. If I hit it up, it's right there. Scraped it. So for pulling individual tables or lists, like HTML lists into a document, I would say, find ways around that. You don't need to write a scraper for everything. If you need to operationalize this, Google Docs has an API. You can reach out, you can pull the data in any format that they want to give you. I think that's XML, download a CSV, which is what we did, or I believe JSON as well. You can also just use the UI to download it if you need it once. In our case, these values changed annually. So it's done. So just quick tip on the side, anywhere you can gain efficiencies and automation, take it. So that in mind, let's get into scraping. Time for Python. So just to review the strategy, we've got a discovery phase, a research phase, design and validation, and implementation. You'll see in practice that sometimes you don't necessarily need to separate design and validation from implementation. In this case, if it's just a table, or just a list of things, you don't need multiple sources, you probably don't need a subset of your data. Your subset's right there. You don't take 3 rows, right? So with this in mind, we've got 3 sites. We're gonna look at prospect lists from Fangraphs, from Baseball Prospectus, and from MLB.com. And from each of them, we're gonna find 3 different ways of acquiring the data. We're gonna kind of probe it a little bit, or figure out where it is, and we're gonna acquire. First question, what do I want? So the 2019 top prospect lists from those 3 publications is our target. That means we're going to be looking at a system identifier, because in our data source we need to know where we acquired the data from. It would be MLB, FG, BP. We want the system player ID, such as the BP ID, Fangraphs ID. We need the rank and then the player name. If you wanted to extend this, you could also bring in position and team name. This is where things get fun. I left that out because it's just a little too unstructured on each of these pages. The team name could be a 3-letter code. It could be an MLB like integer, or it could be the entire like Chicago White Sox spelled out for you. That sort of resolution comes after the scrape, so I left that out in this one. But this is our core data model. And to start, for those of you familiar with Python, who's familiar with requests? Yes, awesome. Okay, great. Has anyone here used requests HTML? Excellent, even better. What about LXML? Beautiful soup? A little bit? Great. I like it. ScrapeEye. Excellent. You should be up here. So again, if you want to follow along, that's the repo. We're going to use these libraries to fetch via HTTP the pages, and then we're going to use them to actually like break down that HTML, make it traversable programmatically so that we can find the individual elements that we want. And then we're going to use the developer's best friend, Chrome's inspector panel. Chrome's inspector panel lets us look at what's called the document object model, which is kind of like the realization of the HTML inside of the browser. Lets us move through each individual element, see the text, see styles if we need styles, things like that. Gives us kind of like a living, breathing way of looking at a page. So as you actually scrape, practically speaking, here's what the methodology looks like. You load a page in the browser, inspect the page in the source. If the data's present, you're good to go. But if the data's not, you have to do a little more research. In MLB's case, we'll see that it's just not. Then you want to go over to either Python or curl or Postman if you use Postman as an application, and just load the source programmatically. Make sure it actually comes in as you expect. You will eliminate a lot of problems doing this, and you will find that not everything is always there. Then on to scraping code. This is actually pretty repeatable. Like really, it's just about probing. It's about finding what's on the page and what's not, about understanding the format, understanding like what broken HTML you might need to heal, and then specifically like where individual like units of data are. So let's start off with Fangraphs. I'm going to spoil it for you and just tell you it's in the table. But I would also like to, if you'll entertain me, flip back over here. This is what Fangraphs looks like. This is their top 100 prospects page. So we see this and we see, okay, we've got the rank, we've got the name. Don't have the ID, but if we hover over here, if you can see the hover link at the bottom left, it does have in the URL player ID equals SA9 and then such characters. And it looks like each and every one of these has it. So I'm gonna zoom in here. That's our first assumption, is that we need to check all of these URLs for a player ID. As we go, things look good. Generally speaking, looks like they've got a bold style on the link. That's good to know, because as we get down to number 78, blah, blah, blah. What a great name, DL Hall. Colwyn. Colwyn does not have a Fangraphs page, ergo Colwyn does not have an ID. This is an edge case we need to be ready for. So the other edge case here we need to be ready for is this. Inside of the structure, we have table rows. This is just your bog standard table. Each of these players lives in a row, and then you get to another row, and you got that. So what's the difference between the two? Does anybody see the difference already between the two down in the inspector? Take that as a yes. So all the rows with players use the TD element. It's just a table cell. You come down to the divider here, it's using the TH element, table header. So we can differentiate on that. Using that, we can build a little bit of logic to say, as for each row in the table, if these cells are TH, skip it. If it's a TD, continue. Does that make sense? So that's kind of our logic. So we've got the assumption that not every player has an ID, and we know that rows with TH in there, we should skip. Now, sometimes you don't get those indications. If this was a TD, then you need to maybe look at the class attached to see if the background color is a differentiator. But in this case, we're good to go. So back here, cool. So we know we're looking at table rows, and we can scrape that. Does the page load programmatically? Let's find out. Do we have any blockers there? Oops. Looks like the page. Scroll up, sure we can find, yep, there we go, cool. So we validated that it's not gonna be blocked by a firewall, anything like that, pretty cool. Now, let's come back over here. Do we have in the source that information we're looking for? Let's just take Vlad Guerrero's name, so we know it's in the source. If we were to view the source of this page, this rotten looking HTML has Vlad Guerrero in it. It's got Wander Franco, it's got Fernando Tatis. We can come back over here and we can assure ourselves why that's exactly the data we need. So we have everything we need right in front of us. Just again, there's an example of that if you want to go back when the deck is out after the slideshow. So we know the page loads programmatically, 1 row per player. We have columns for the information we need. We do have an unstructured divider that necessitates logic, but we know that we can use our old friend XPath here to continue, and we know that not every player has a page, so no system ID. So if you are following along at home, here's what the code looks like. So we're going to bring in requests HTML. We're going to use what's called the HTML session. That is a special helper, it's like a wrapper around the normal request session that just gives us access to the underlying HTML in a way that we can programmatically get at. So we're going to call the URL, and this is just a safety mechanism that'll stop execution and raise an exception if something went wrong. Ideally, if we're operationalizing this, we'd have something else monitoring that. We could log it, inspect it later, come back and fix it. We're going to set up a CSV writer. Again, all standard stuff. I'm sure you've seen this before. Here's where it gets fun. So at this point, we've loaded the page, we have the HTML, and we've breathed life into it with this special HTML attribute that is part of the HTML session inside of request HTML. So this gnarly bit of code is what an XPath is. I've broken it up into different lines for visibility, otherwise it's about the length of this stage. And we are coming down in here, we're looking at a div element that contains a class called fullPostEntry that has a child div with a class of table container and then table wrapper. And then we're looking at the first table inside, going to the table body, trtd. So right here, this trtd in this kind of ugly XPath is exactly what we're looking at to say, only give me the table rows, the tr elements that have tds inside. And then we're going to back up. This dot dot, just like in Linux or Windows, I'm sure, would let you literally back up to the tr. So that's going to give us all of the table rows that have TDs, and from there it's just a simple iteration. So using that same method, we're going to use find on individual elements. We're going to say for every row in the prospect table, literally every TR, we're going to find TDs. We're going to say just give me the first one as a convenience method, and we're going to get the text inside. This, line 49, maps directly to this number. This is the first TD in the row. This one is the text inside, and we can just kind of confirm that loosely right here. So we got TD, and in this case it's 80. From here, we're using a CSS selector and saying give me the nth of type, which is a function that lets you specify in a 1-based offset which, let's say in this case, TD you want. So we're taking the second one. We know that's where the player information lives. That maps literally to this. So we're saying give me the second TD, which I've highlighted here, and we want that A attribute inside. But we know that not everyone is going to have an A attribute. So sometimes we need to look at the text, other times we need to parse the A. So we're going to come down to here. This is where we look to see, is there an A attribute inside? If there is, this is the fun part. Right here, we're going to take a look at the URL by getting the href or href attribute of the A. We're going to parse it with Python. Long story short, we're going to break it down into its 6 components. We're going to look at the query string specifically, which is everything after the question mark in the URL. We're going to take the player ID from the player ID attribute, which if you remember, if we hover here in the URL, here, I'll just click it. I said I'll click it, would be this part here. Then we're going to take the player name by just taking the link text, and strip is a convenience method in Python for strings to eliminate white space from both sides. So if that A element does not exist, we don't have a player ID, and we can just take the text straight from the cell, which means TD, whatever text is inside, close TD. From there, output a uniform interface, and we're done. So when you run this, you get something that looks like this. If you're on GitHub, You open up the CSV file, it'll format it for you. But yeah, here we go. So we've extracted with the key of FG, we have the player ID from the URL, we got the rank, we got the player's name. Word of advice, if you're gluing this stuff together, please never, ever, ever use the player name or any sort of like data like that. Always use system IDs as much as you can. You're not always going to have them, and sometimes you have to fall back to parsing names, but names are, names can be a little unstructured. You're going to get cases where there's a comma between Guerrero and Jr. You're going to get cases where it's Guerrero Jr., comma, Vladimir, right? Don't rely on that unless you absolutely have to. So we specified what we wanted. We researched it, and we saw that it all exists inside of table rows. We went to the table rows, and we extracted that data. Before we did that, we saw the code is in fact on the page. We viewed source, simple enough, but it's not well structured, right? There's not like a hard schema that enforces all of this. We had to work around the inline divider lines, and we found that not every player has IDs. So knowing that, we worked around it. That was just our simple if logic. We took it all at once because it's just one table sitting right out in the open. If you're asking yourself, why don't we just throw this in Google Docs? That would be because we had to take the player ID using logic out of the URL by the query string. Cool. Questions about that before I move on? Nope, good, okay. So next up is baseball prospectus. Got this one open here. Cool. So baseball prospectus publishes a top 101 players list. Very fun. Theirs is just about as unornamental as you can get. Very unsentimental about design there. That is both good and bad. In some cases it's good because it keeps a lot of cruft out of the way. In other cases it requires just like even more freeform text parsing. So as we have here, as you can see down here, each item in the list is inside of an ordered list, and you've got one LI element per player. As we go down, what's the repeatable element we can find in each of these? This, it looks like the player is wrapped in a player def class inside of a span. Is that the same for everything? Yes, roughly. So as we go through, we can start extracting that way. Yep, looks good. So with that assumption in mind, what else do we need to do? We know that we have inside of each player def, just like we had on Fangraphs, a URL to parse to get the ID and the name. So is the content on the page? Let's look for Vlad Guerrero's name in this basic format here. Yep, looks like it is. Cool. So there's Vlad, comma 3D, 3B, team def. Okay, so we have fairly repeatable elements. Notice here that Joe Adele is not in here, so one of our assumptions will fail in this scraper, but it looks like most other players are inside of player def. This is what happens when you build your lists by hand. It's very good to have sequential data automated for you, so be ready for that. So we know it's on the page. We know what structure to look for. We have a repeatable element. We can target it. We know instead of a table this time, it's going to be list items. So really, we're just kind of swapping out what we expect. But does the page load programmatically? Maybe it does, maybe it doesn't. So what we'll do is try to load this just to confirm our suspicions this way. Let's see the information there. Okay, so it does load this time. That's good. Baseball Prospectus also has a bot layer in front of it, which apparently does not want to do work during the demonstration. But pretend like it worked. Pretend there's still a bot layer there. So we've targeted our information. We know the repeatable elements we're ready to scrape. We've got one list item per player. Player details reliably wrapped, mostly. We have to infer rank from the list. We don't have an attribute to target that specifically dictates the rank like we did back on Fangraphs. Player name and system ID are available though. Not every player has a page, so we're gonna have the same situation. This time, instead of looking only for a URL, we have to switch the URL that we're looking for. Baseball Prospectus specifically will have a card page for everyone that does exist in their system. It'll be card.php. If they don't, then it takes you to the player search page with the player's name in the URL. So we can vary on that essentially. The page does not always load programmatically. That's because BP will block people if they sense that you're trying to scrape them. If you go in with requests and just try and scrape it right now, it will throw up, I believe, a 503 error and sometimes a 403 error. The 503 is, of course, concerning because that means something went wrong. But that bot protection layer is something you're going to encounter quite a lot. So if you spoof the header, as we call it in the biz, and just send something that looks like the real user agent string, a real browser identifier, it will accept your request and continue processing. So that's a good point to make generally. There are going to be times where you might scrape one page and on the next page nothing happens, or you load something in the browser, everything appears, you're going to go over to your client, your Python interface, whatever, and you try it again and it doesn't work. The difference there could be the user agent header. It also could be that on your first visit in the browser, the site sets some cookies, and on subsequent requests, it looks to see those cookies exist, right? That means you're going to have to kind of do a little bit of research into where the cookies are, what the values are, and then send them back programmatically with every request. You need to encapsulate everything the server expects to make your request. So if you hit that, it's a good thing to keep in mind. Again, like Fangraphs will hit reCAPTCHAs. There are also times where you're going to not be able to use Python because Python can't simulate every aspect of the browser, but it can, with request HTML, wrap an application called Puppeteer. Does anyone here use Puppeteer for scraping? Yes, I thought I'd get you guys at some point. Okay, so Puppeteer is essentially an API around Chrome. You have a headless or interfaceless version of Chrome that you script. You can say load a page, and then you can manipulate all actions through. You can simulate clicks, fill in forms, do whatever you need. Then, programmatically, you receive the next page, next page, next page. So with that, that's as close as you can get to actually pretending to be a user on a site. A lot of times, if you are doing user testing, let's say like you build websites and you want to automate just to test like credit card entry works, something like that, you're going to be using the same thing. There are times when, say, Cloudflare is there or whatever, that using Chromium will get you around because it will pass the cookies on for you, pass authorization, et cetera, et cetera. Give it a look up if you want. So we scrape, and what do we see? So in the scraper here, we did not account for player def missing, so we are missing Joe Adele, and our rank is off. But we can see here that we've accounted elsewhere for missing data. And if you want to take a look at the scraper, it's nearly identical to the Fangraphs side. We come in, we start. Here we specify the user agent because typically with like requests, it will fail if you don't do that. Our user agent up here is just, whatever. So we come down. In this case, we're using a CSS query. So we're using that same response.html.find method. And this is going to give us all of the player def A tags, all the players as other elements that are on the page. So because we have to infer from the list, we're going to use Python's enumerate function. For every item in a list, it's going to give you the index before it continues on. From this, we can build a one-based rank. Again, just going to extract the href attribute of the URL. That's going to be the URL that we parse. And we can see if the URL contains card.php, then we need to parse. If it doesn't, it's a player search page. It doesn't matter what it is, we're done. From this, we can get the name, we can get the rank, possibly the player ID, and write it back out. Any questions about that?
How would you get Joe Adele?
Excellent question. Buys tons of time. So in this case, what you would do is you would change your logic to not look for player def. You still know that inside of this, let's see if I can zoom in on that. There we go. So you have this list element. It doesn't matter if there's a bold tag there. You're expecting a span with player def. That's not there. So what you do have is still that typical A tag. And you can look at all of the other list items and say, in this case, we can probably assure ourselves that even though player def is not there, the A tag is relevant. If you wanted to, you could even look at the href and match it to a known set of URLs that might be either like search or card.php, things like that. You would essentially just remove there and make the assumption that the first anchor tag inside of the list item tag is a player. Cool. Anything else? Cool. All right. Sally forth. So we've got that. And then just to review real fast, got prospect information from items in an ordered list, one player per list item. We looked at it. We said it is in the source. We don't need to load an external data resource. It's semi-structured with fairly reliable player def class. That proved to be false. For the rank, system IDs, user agent header, we took it all at once. Excellent. So finally, let's look at MLB. Doing all right on time. Cool. So MLB's fun. MLB has a dynamic page. You guys familiar with Ajax? You know what that means? Yeah, ish. Okay. So you don't always have to have your data on the page. Sometimes you can call out to an API that serves you a blob of data and then just drop that into the page. Some people use JSON for that, others XML. Some people render HTML because they're perverts, and just drop it right in. So this is what that page looks like. So when you load this page, it looks like it has information there, and then everything flashes in. It's great, right? So I'm going to look at this and say, okay, what do we have to work with here? Got a consistent data structure, looks good. We even got the player ID as an attribute. That's nice. That might come in handy if we have to move through the DOM. All the information seems to be there. Let's look for our good close personal friend, Vlad Guerrero, in the source. Vlad, uh-oh, he's not in the source. Let's look for Fernando. It's not there. And that is because if you dive into the source code, you will see that this is loaded remotely. All this information is not there when the page renders. The page then calls out, for whatever reason, for the 2019 API resource, and then loads in a giant blob of JSON. That JSON is then used to update the page with what you see. That's why when the page loads, everything here is blank. So, again, what the hell? So we looked through here, and we need to hit the network tab and figure out where this data is coming from. This is a pretty important technique, so let's do it together. So, network. The first time you load the network, it's probably not going to be there if you don't have the console open, so I'm just going to refresh. You can see it populate. Player prospects.json. And as I hover each of these, I can see a year in the URL. I feel like that's a pretty good tip. Let's explore further. Cool. When I look at the response, here's a data blob sent back. So I've got prospect players, and I'm going to kind of look through these. Mike Soroka, ATL, that lines up. So here's all of Atlanta's prospects. Keep scrolling, and I've got somewhere in here a very nice list of just all actual prospects per year. So this data blob, I'll just open a new tab if you want to see it formatted. Looks like this. MLB, in their infinite wisdom, has this JSON endpoint where you can, for a specific year, go get prospects by team and then prospects all together. So I need to do a little scouring inside of here and figure out, I don't want Atlanta. Looks like we've got an entry for every team. I'm going to jump to the end and just give it away. You've got a prospect entry here. And this is an array of all of your top prospects. Look at this beautiful semi-structured data, even with the thumbnails. It's awesome. So our job is pretty complete at this side. We've gone to the network tab. We did a little poking around. I know we fast forwarded, but it's really the same everywhere. You're not always going to get lucky. Sometimes it's a little buried. Sometimes you're going to have minified scripts that load other scripts, and you got to do a little bit of tracing. But in this case, it took us right to this API endpoint that we can go to directly. We don't need to go to the MLB UI page. We can go directly to the data source. And we can see that we've got the player ID, first and last name, that we can glue together. By God, we've even got the rank. So we have everything we need. Yep. So as we cased it, we saw that it's in JSON, it's well structured, no ambiguity around the player IDs. We're good to go. Let's look at it. So boom, this is what it looks like when you scrape. And let's take a look at the code. Cool. So in this case, we don't even need to request HTML. We can just make a basic HTML request, or just a basic HTTP request. So we're going to do that. We're going to use just the request library to grab it. Here we're going to raise for the status again. Same writer code. Ideally, as you're building this as a library, you're reusing your code, not just copying and pasting like it did everywhere. And then we're going to use the convenience method on the request response called JSON. And this method takes the response, which is JSON, and turns it into a Python dictionary for you. From here, prospect players, that we can just grab inside of the dictionary that same prospects key I showed you, and we're good. So we can write the system ID, we got the player ID, no transformations needed, we can glue the player's name together, and we are done. We now have a prospect list for each of the big three providers. Very simple code, very legible, nearly plain English. We did not have to strain credulity to get there. So with that in mind, JSON API response, we discovered the network tab. Code wasn't on the page. Good thing we explored, and we got lucky. We had pretty well-structured data on this side. So those are the coding demos. We've got about 15 minutes left. So let me wrap up, and then if anyone wants to explore, we can do that. If you want to end early, by all means. But I just want to leave you with just the idea, we have a framework that we applied 3 times. The framework saved us a lot of time and a lot of questions. Always conceptualize where you want to start. In this case, we had the idea of the prospect lists. You're going to have your own ideas for what you would want to scrape. But make sure you understand the output that you want. Make sure you understand why you're scraping this. Make sure you can visualize where you go next with it. Because if you don't, you're going to scrape bad data and have nothing to show for it. Apply the framework, save yourself some time. I would highly encourage you, not just my beautiful scraper code, maybe the most beautiful in the world, to find other scrapers for sports on the web. Just read as much of it as you can. When you're ready to move on from single scripts, like what we wrote today, look at ScrapeEye. ScrapeEye is a beautiful framework that will handle like operationalizing all of your stuff, but also scraping in parallel. So if you have, let's say, like 8,000 Fangraphs player pages for 2018 to parse, it's going to help you like spider that out, and it's going to control your concurrency so Dave doesn't come back and blop you. It also will let you deploy into production and manage all of this stuff. If anyone's interested, I can show you what it looks like on my side. And I would say, go look at other APIs. Scraping isn't just writing a script to pull something off of a page. There are plenty of APIs out there that will help automate this with code you and I could never write because we're not Google, right? We don't have the smartest people in the world working for tens of years on this stuff. Mercury is an API run by the kind folks at Postlight that will, much like if anyone uses Pocket or Instapaper, go to a web page and extract critical information about it. Get you the author name, the publication date, the title, some of the other structured metadata about it. Some of it's best guess, some of it's a little sloppy, but it works really well and it's free. IBM's Watson, a lot of smoke and mirrors. I know it lost on Jeopardy, it's pretty good. But Watson acquired a company called Alchemy API. And Alchemy is one of those companies that did a lot of natural language processing. So you can throw an API, you can throw a URL or just a blob of text over to Watson, and it will analyze it for you and start returning, as I'd shown earlier, like Bryce Harper, organization, Los Angeles, city, things like that. And then Google Cloud naturally. There are a million APIs like this. Go look at them, figure out what you want to do with it. Make your information like as rich as possible. So with the remaining 12 minutes and 50 seconds, what questions do you have? Do you want to try anything live? I'll open the floor.
Kind of best practice.
Oh, awesome.
My question is not about scraping, but just best practice for the edge cases.
Mm-hmm.
Like the NHL, for example, has their API where they have shots and goals and XY coordinates for all of those. But for whatever reason, some games, they didn't code the X or Y. So would you just ignore those games, or would you try to figure it out in some other way?
I would try and figure out some other way. And this is a little bit of dangerous advice, but what I would do is the same way we handle information with MLB's StatCast API. And just as background for everyone in the room, StatCast has some problems. StatCast loses pop-ups, right? Because cameras are focused on a certain area of the field, and if a ball leaves that field, it's gone. It's also doing computer vision. So if a piece of trash blows across the field and the piece of trash looks like a white baseball, it's going to record the baseball going this way and then the baseball also going this way. Little quirks like that. It also can't handle, and this is what I'm building to, collisions. So if you've got 3 fielders and a runner all like converging upon the same point, it can find before and it can find the moment of convergence, and then where things go after is hard, where the ball goes after and where the players go after. And that's where you have to start kind of like imputing the data. It's tricky, and it requires some like time series techniques, such as like if you have segments afterwards that you can look at. Maybe you do with the NHL data, or is the entire play just missing X and Y? Case by case basis. If you can impute the data given like time series-esque like observations X, Y up into that point and then after, you're probably in pretty good shape. If the time segment just ends there, you could look at the subsequent play or like where play resumed maybe in the next observation, but that you might be out of luck there. At that point, you probably want to go to the video. Thanks for your question. Okay. Cool.
The NHL, one Google, which is aggregate statistics on win-loss, whatever.
Okay. So the question is, what's the best place to go to get like NHL box scores? Could you get it straight from Google where they've got it nicely formatted? Or should you go somewhere else? In that case, I would specifically avoid scraping Google because they're very feisty about that. I would go directly to the NHL and I would start looking at specific like box scores. I do think that the NHL uses the same platform that like Major League Baseball does for deploying their websites. I want to say because of that, you should be able to find box score data just kind of like by poking around the pages.
And do you think you'd be able to figure out where, like starting at Google, so you didn't know
Oh, sure.
where source is directly from them, or you just sort of have to?
You would have to investigate a little bit. So I should have had this as a preamble. Yes, be very wary of terms and conditions. Robots.txt is a convention for saying what is and is not allowed to be scraped. StubHub has an API. You can sign up for their API and access their data programmatically, legally that way. If you want to scrape them, kind of at your own risk, not saying don't do it, just for the thrill, but yeah, you really could, yeah. So a friend is looking at doing like ticket modeling with StubHub to find arbitrage opportunities, you know, as the rest of the world is. That's exactly what he's doing. So he wants to go through and find how much did tickets sell for, like historical data. StubHub gives you a little bit of that, but if you're constantly scraping to find like prices up till the time of the event, you can probably surmise from that. Yeah. As for the methodology, yeah, exactly that. Yeah, StubHub is just on the web. Some of their data is loaded asynchronously in a JSON format. The API should communicate in JSON as well. You should be able to look at that to figure out where the data exactly you need is. The verbiage for the legality would be on the site, yeah. Any time you sign up for an API, especially something from like StubHub size, they're going to have like a terms and conditions up there. One of those terms might be, don't use this to compete with us, but it's never stopped anyone before.
So first of all, sorry if I'm really loud. Great talk. I think it's wonderful.
Thank you.
Having done this in both R and Python, it's amazing that you did it in Python. It's so much easier. But I have a question. You mentioned sort of an entity resolution problem sort of in the beginning about like how the team IDs are represented in a number of different ways. Mm-hmm. Do you find that you often have to roll your own ER solutions, or can you talk a little bit about it if you did use tools for that?
Yeah, for sure. So, I lost myself there. I want to look at my password. Okay, so just to go back, we have, screw it. So the question here is, how do you resolve entities? Is that a fair approximation? Yeah, okay. So again, we've got 3 systems here, each with their own vendor IDs. You got the Major League Baseball ID, the Baseball Prospectus ID, and you got the Fangraphs ID. Yeah, that's. I don't have time for that, man. Instead of building your own entity resolution system, which you absolutely could, the first thing to try, just go on the web and find one. There is the Chadwick Register, which has historical information going back, long to like the beginning of baseball for every player. That information is like the date they first played, the date they last played, but most useful in this is IDs across all the different systems. So you get your ESPN ID, your CBS ID, RetroSheet, BP, anything under the sun. What they don't have is a lot of fantasy platforms. And so that's where something like Smart Fantasy Baseball's ID register is going to be really helpful. There's also one from Crunch Time Baseball. If you want an interesting Twitter follow, the guy from Crunch Time is up there. But what they've done is they've gone, to the National Fantasy Baseball Championship site. They've gone to several different like prospect ranking sites and accumulated all the IDs. You're not going to get players from cutting in here. You're not going to get players from like 10 years ago. You're not going to get players necessarily from even 5 years ago, but you are going to get players from the last 2, 3, 4-ish years. Yeah. I mean, that would be a fantastic opportunity to write scrapers to go to, ESPN to CBS and start accumulating ID hockey players, soccer players. Cool. 5 minutes left. Anything else?
Do you mind just repeating the Google Chrome package that you have to show the table structure? Just the name of it or how you downloaded that Google Chrome add-on?
The package for showing which structure?
The Google Chrome add-on that you had to show the table structure and like the HTMLs on the.
Oh yeah. So that's not actually a package. That is built into Chrome. I assume you're talking about this.
Yes.
Yeah. Okay. So if in Chrome you press I think in some browsers Shift Control I, or just enable the web developer tools, you get access to a lot of stuff around here. What's that? That's too few keys. Got to work for it. Running Linux here, man. Internet Explorer, it's definitely F12. I don't know about Chrome. Is it? Okay. This guy says F12. In some browsers, like Safari, you have to enable developer tools. They try and hide it from you. But if you Google, let's say you're using Chrome, just Google like the console, just network elements, anything like that. Cool. Yeah, of course.
Any thoughts on scraping off of like proprietary things like PDFs?
Yes, a lot. So are you looking for just anything, or do you want tabular data, or?
So specifically, each race weekend, NASCAR puts out this massive amount of information,
Mhm.
but they release it to the general public as PDFs.
Oh, okay.
So that's how they do it, and then I can gain access to that easily. But then putting that data in a meaningful way takes a lot of copying and pasting
Yeah.
from PDF, from Adobe's, Adobe's software that I buy, and I have trouble getting that to.
Yeah. So it does. Yeah, it's real labor. A couple of thoughts. If it's tabular, Microsoft just released today an app that will let you take a picture of a data table, like in a document, and it will convert it into like an Excel form for you. Good example of screen scraping. If you want to do this on your own, let me bring this up. Apache Tika has the ability to be run just as a server, and you can make an HTTP request to it, or you can use it as the command line too, just for converting from PDFs. You give it a PDF, and it will output in a specific format. HTML is the one I prefer, the data within, and it will try and structure it as closely as possible. The one thing about PDFs you really need to look out for is they're a horrible, hostile format, and will screw you at every turn. You might have a sentence, right? Just 3 words. The first 4 letters of that sentence, might be like a space away from this. I would love to talk in detail if you want more horror stories or just like general tips with that. We OCR'd a bunch of old newspapers from my father's hometown, and then tried to make them searchable so that he could search the last name and put together like a document of the history of the family in the newspaper. No jail, thankfully, but inside of that, Tika was wonderfully helpful. Time for 1 or 2 more?
I have the mic, so I'm going to use it here. As sports betting is now legal and becoming legal in most states, just a matter of time, do you have any recommendations for scraping data from bookmakers and such in order to utilize data almost in real time for betting?
Yeah. I don't know those sites well enough, but I would assume that if they're publishing the information, and I guess this is kind of the crux of the talk, if the information is on a page, you can find it and scrape it. It kind of comes down to whatever format they put it out there with. I would also anticipate that, I don't know if FanDuel or the other one, DraftKings, have real-time APIs. I know they're working on them. But I would look into what like sports APIs exist today that push real-time updates. I think the folks from Stats out in the hallway have one, but it's not within the price range of the normal human being. So I would look for those. You could also just have recurring scrapers if you want the real-time data hitting Major League Baseball's APIs, other sports APIs. In fact, just to give an example, so Baseball Savant is a site that was acquired by Major League Baseball, has real-time stats on there. If you, just as a lesson, let's apply the method. So we want real-time states, daily matchups. Just nothing going on today, huh? So we're gonna load yesterday's matchups. Okay, While this loads, let me explain. Baseball Savant will show you tables of real-time data about a baseball game. That means there's a real-time data feed. That means if you go exploring in the network panel, you can probably find that real-time data feed. Your obligation then would be to take that data feed and continually read it, bringing in all the stats, accumulating as you go. One edge case to look out for is data corrections. A stringer changes the rule from a foul ball to a tip or something like that. Look out for that. But in this case, yeah, you would just be looking at, we're getting murdered here by the network, but yeah, you would poke around in there and find the same thing. That'd be a great way to get started. All right, I think we're counting upwards now. Cool, nope, all right, that's it. Thanks everyone. I'll be around the hallways, questions, thank you.